All right, so for screencast number 5, we'll be talking about the Laplace transform. And basically what the Laplace transform does is it works by taking a discrete function and then after applying the Laplace transform to the function, you get a continuous function. And to do this, you would apply this equation right here, Kernel's equation, which is just e to the negative st, f of t, and f of t would be the function that you're trying to make continuous. So this is just like a brief overview of what we're doing. This was from another class, so I don't really want to include it. But to go to the problem that we'll be talking about, we have f of t equals 0 and f of t equals t minus 3. And these are the conditions in which we have to prove it under. So you have to prove have f of t equals to 0 from 0 to t, and then less than 3, and then t minus 3 for when t is greater than or equal to 3. So as we learned in our homework, when we apply the Laplace transform to a function, you apply Kernel's equation times the function. But in this case, our first condition is 0. So this whole first part would just cancel out to be 0, but then our second condition is t minus 3. So you have Kernel's equation multiplied by our second function over here, t minus 3. And then our conditions would be 0 to 3, because that's what we have up here. And then for our second conditions for the second half of the piecewise function, would be 3 to infinity. So that's why we have 0 to 3 here and then 3 to infinity on this side. So then, like I mentioned before, this whole first part would cancel out and equal to 0. So after you come down to this part and you do the integration, I don't want to go by the integrations one by one because that's not what this lecture is about. It's about the transform. You simplify it down to this. And at the end, the answer that you get is e to the negative 3s over s squared. And the graph of that looks like this. You would ignore the left side because it's the initial conditions that we plugged in, but looks like what this is on the right side. And that is it for the screencast. It was pretty brief, but the Laplace transform is a pretty brief process. So thank you.